OK, well, the first thing I have to ask you is graphene, what exactly is it?
Graphene is a monolayer, an atomic monolayer of carbon. And because it's so perfect, it's imbued with some amazing properties. So it's basically a flat layer of carbon.
That can do what?
Well, carbon, the sort of carbon that you would recognise would be a bit of coal. It would be a graphite pencil, for example. And actually, I think the Manchester people first discovered graphene by using a pencil and a piece of sellotape, and they peeled off the sellotape, and there was the graphene. So the applications that we anticipate are going to be in the area of electronics, because it has huge conductivity. And so that will enable us to do things that we can't do at the moment. It's also transparent, and it's a transparent conductor, which makes it rather interesting. And that means that we could use that for example, screen displays and so forth. It has extraordinary mechanical properties. It has huge strength, absolutely enormous strength, and it's very, very stiff indeed. So you can envisage making tiny little cantilevers that would vibrate, and you'd be able to then use that as a detector. So I think that we're just scraping the surface of this particular technology, and it's very exciting indeed to think what we might be able to do with it.
And the money that the Chancellor has announced today specifically is to get you to imagine what you might do with it and what commercial applications it might have. Where might we see people making money out of graphene? OK. I suspect that when you make a discovery, you've got to be patient, and you have to generally, from invention to commercialization, takes anywhere between 10, 15, 20 years. In this case, I think that there are a number of aspects of graphene that make it amenable to rather earlier commercialization. So I think the flat screen displays, for example, we might see some aspects of that moving in rather sooner, maybe the 3 to 5 year frame. The composites that we're interested in looking at Imperial would be used simply because of graphene's extraordinary strength and its huge elasticity, its elastic modulus. So I think that we will see applications, but those particular applications, the strength and the stiffness ones, may come a little later. Some of the biggest manufacturers in Britain are obviously interested in it because they're putting funding in as well. Rolls-Royce, BAE Systems, Dyson, all clearly can see the commercial potential in this. If they're prepared to put in millions of pounds of funding, why do you need government money as well? Well,
the funding that companies generally put in is generally in kind. So when we go to Rolls-Royce, we need to make use of their expertise. We need to make use maybe some of their test bed facilities. Same with Dyson, same with Airbus and so forth. So we need those companies in order to test the experiments that we're going to be doing in the lab. So if we come up with a prototype, we need them to be able to help out. And that costs them time and money. So they're putting their funding in kind.
If graphene does have the potential that you imagine it might, somebody's going to make a huge amount of money out of this eventually once the commercialization really is in place. If it's taxpayer money that's going in now, are we going to see the profit?
I think I think the idea would be if you put money into the universities, you get invention, you get devices coming out of the universities, and that will be commercialized. If we put money, if we invest in the UK science budget, then I think you'll see commercialization coming out in collaboration with our industrial partners. So it's worth it.
The idea is to make Britain a global hub for this. Why does it matter that this is done here?
Well, it was invented here at Manchester, and I think that if you get a Nobel Prize, then the goal is to commercialize where you make the Nobel Prize. And so the Manchester people who won the Nobel Prize, they are the hub of this recent announcement, actually. And then there are several other universities that will act as spokes to commercialize, and well, not necessarily to commercialize, but certainly to bring this interesting material closer to commercialization. That's the idea.
And so when will we be buying graphene products, do you think?
Well, you need a crystal ball for that, and I haven't got one. But I would suspect within the 3 to 5 year timescale.
Pretty quickly?
I hope so, yeah.
Great. Professor Neil Orford, thanks very much for coming in to talk to us about that.
Thank you very much.